Well, good morning or good afternoon, everybody, depending on where you're coming from. Welcome to the Fusion Studio First Friday event here in October. My name is Rich Dione. I'm the co-director for the Fusion Studio for Entertainment and Engineering here at Purdue University. With me, as always, is my colleague from the College of Engineering. I'll introduce yourself.
Mary Pilot, co-director of the Fusion Studio. Welcome, everyone.
Fantastic. Also, we're thrilled to welcome Eric Hall, who is technical director for Disney Live Entertainment. And I should have the number in front of me, but I think it's about 20 years, but I don't want to say that out loud in case it ages him in a way he doesn't want us to do. But we're also secretly proud to announce that he's an alum of Purdue Engineering. And he's going to talk to us a little bit today about Disney's Design Assurance and Hazard Assessment Program. So welcome, Eric.
Thank you. Yeah, actually, I guess I can be comfortable with the number. I just hit 26 years with the company.
26, goodness.
26, yeah, back in July. So it's been a long road, but it's been a fun road, and it's definitely a unique experience working for the company in various roles. It's quite exciting at times to get to do something different every day. So
that's fantastic.
So yeah, let me share my screen real quick. I'm going to talk about our design assurance hazard assessment process, and just to encapsulate real quick. We started this program. I don't know exactly when it started really being implemented because it's kind of been rolled out, and now it's expanded a little bit, but it's probably been at least 10 years, if not more, that the company's rolled this out in terms of, and I want to say this from a perspective of live entertainment. So we have a process that we follow, and the other departments have their processes, which are very similar. But we implemented this process because we do so many things. We work with so many vendors, we do so many different things and so many unique things that, you don't buy off the shelf or that people haven't done before. So a lot of what we do is more or less, we're testing the waters on a lot of things. And so this process helps guide us through what are we thinking through, how do we make sure everything's safe? So let me see if I can share this and get started here. And there we go. So anyway, this is what we call the design assurance hazard assessment process. It's basically what it is. It's basically it's a program that provides oversight, design, engineering validation, hazard analysis, quality control, quality assurance, acceptance, and turnover. So what that means is we start looking at things from as soon as pencil hits paper. As soon as we bring in, we have an idea for a show or for a show element, and we say, okay, well, what is this? What are we doing? Are there any hazards to it? Is there something that we need to make sure that gets incorporated into this design, that it's going to make sure that it's going to work? So the purpose of it is to ensure the safety and compliance to our national, local, and our company standards for a project or event. A lot of times our company standards are a little or more stringent than our maybe a national or local. And we also work with Reedy Creek Improvement District for permitting for things such as like outdoor truss or scenic pieces. So we have to make sure that we comply to all the codes and our own standards. And then we also, the purpose is that the show element is validated to operate as designed. That we make sure that if something is being fabricated that either has mechanical or even if it's just a static element, we need to make sure that it's validated to operate as designed. It's not going to fail on us. It's not going to warp, or if it's a piece of scenic, it's not gonna fall apart, that sort of thing. And then also the process gives the operators and the maintenance teams the necessary training and the documentation. So we have to make sure that whatever we're putting in, that the operators, the people who are running the show or running that show element, understand what it is and to troubleshoot if they have any problems. So and this process starts from the beginning. It's, you know, that we don't bring it in halfway through. We engage these teams from the get-go. So it's super important to do, because there a lot of things get caught early in the process, or things we have to think through. And who is involved in it? Basically, the live entertainment technical director is responsible for the effort. So I, as a technical director, I take the ideas that are given to me by our designers, and I look at them and I go, wow, this is something new, or something that we should look at. So I would engage the principal technical director. So the other team members that we have are principal technical director for QA. His name is Chris Wart, and he is extremely intelligent. And he he's basically a computer. He knows pretty much everything. He's just extremely helpful, and he's a great mentor. And then the other team members that we have are a quality engineer that basically helps guide the process. The quality engineer, her name is Catherine Burns, and she basically steers us in the direction of, well, what do we need in order to make this happen? We also have safety professionals that we work with. There are local safety professionals in each park that basically they're the ones that you go to. So if I'm putting in a show in a park like the Hollywood Studios, I would engage the safety professional that works there, as well as we have our own entertainment safety professional that we can go to directly as we are in the design process. And she helps us out with some questions, or it may be just simple things. You know, right now, they're really into what the COVID protocol is. So they basically say, for instance, how far do singers have to be from each other? How far do the talent needs to be away from the audience? That sort of thing. We also have subject matter experts, what we call the SMEs. So when we get into things that we don't know a whole lot about, for instance, lasers, we have a subject matter expert for lasers that will determine what we're doing, if it's safe, if we need to provide certain protocol or certain things like interlocks or something like that, or hard masking for lasers. We also engage professional engineers. We have some professional engineers that work for us in design and engineering, and then we also will go outside of the company to engineering company to validate or to engineer certain things, such as I was just telling Rich, I just sent drawings to a professional engineer who is a Purdue alumni that does a lot of work for us for truss setup for the Run Disney events. Basically, they have to be engineered and permitted for 94-mile-an-hour winds. So what we put on them, we have to validate that. And then we also have our entertainment standards and sustainment folks who basically help guide us through all of the job plans, training, and that sort of thing. So when we do the process, all of these people are engaged, and they put in their input. So basically the process goes is the technical director identified items that need review or a hazard assessment. It's really just one of those things where sometimes you just don't know, and it's just a matter of talking to the people that are in the process and saying, what do we need for this? What's going on? So what we do is we fill out a preliminary hazard assessment. So we basically say, okay, I'm going to give an example for Epcot Forever. We just closed that show. It was a fireworks show at Epcot. We had a show. Then basically COVID, we had to shut it down for COVID, and we brought it back, but it was a little pared down. And excuse, somebody's doing yard work outside. So anyway, we basically say, okay, we're going to have jet skis on the water that are going to be pulling kites, and we're going to be having pyro, and these people are going to be driving around the pyro. And, so we identify all of these things that that basically the show entails and what the possible hazards are. And then then the TD will engage the principal technical director and say, okay, so what standards are applicable? Now, there are certain things that don't necessarily need to have a full hazard assessment. Sometimes what we can do, depending on the complexity, is that we can say, well, we're just going to do due diligence. If it's something that we already have a standard for, like, for instance, we have overhead safety guidelines that we have a standard for. Say we want to put in a piece of scenic inside a building, but our timeline won't let us engineer it for tip over. So we basically, anything that's over 8 foot tall, we would need to engineer it to make sure it's not going to fall over. Like, how is it going to be installed? Is it a temporary piece? And due diligence may say, well, maybe we can tie it off to the roof structure. We would validate what that roof structure can handle, and then that way we're basically eliminating any sort of tip over moment problem that we may run into, that sort of thing. And if we can follow the standards that we've already set, we would just be doing due diligence to make sure as we go through the process, as long as we're following these standards, following the things that we're required to do, we don't necessarily need to have a full hazard assessment. So then the technical director will then contact the, if it's something a little bit more complex, they'll contact the QE to ask if the hazard assessment is needed, and which is even more important, the okay to use memo. And I'll get into that a little bit later, but basically the okay to use memo is basically the, I guess you say the approval to be able to do it into show, use it into show. So that's going to be super important, because there are different criteria and different requirements that would need to be met in order for that to happen. So then if the HA is needed, then the TD will contact the members of the team and ask for an HA process to be executed. So everybody gets together, we schedule weekly meetings or more, depending on, how much we have to go through, what's our timeline, and that sort of thing. Then the next step is once we get together, we identify what the potential hazards are. We create the hazard alignment model, and it identifies the categories that must be mitigated. And basically what it does is it provides the categories of hazards. It also gives a criteria for the hazard to be an H4, H5 hazard, which is H4, H5 is basically like severe injury, possible death, that sort of thing. That's what we really, really concentrate on. Those are the things that we really have to make sure are met. There are lower hazard criterias. You have basically H1 through H3, and those are met. Those are thought through on a different level. And I'll get into that a little bit more. We also, the HAM also identifies the indication of which hazards are known to apply to the project. So there's, we have a list of the hazards, and we basically check and say, well, for Epcot Forever, we're not using any sort of, liquid nitrogen or carbon dioxide or something that's going to create any sort of suffocation hazard, or we're not going to worry about, confined space, that sort of thing. So we don't worry about those. So, but we check which ones are going to apply to us. And then also it assigns the resource or person authorized to provide acceptance of the hazards. So basically that's your subject matter expert, or the QE will assign that to say, well, this person is going to look at lasers, and they're going to approve whatever we do for the mitigations for the hazard for lasers, because that person knows, they're a subject matter expert in lasers. So all of those people are involved in the process. And as we go through and we talk through the process, and sometimes something's easily mitigated and then they don't have to be involved anymore but if anything changes, then obviously they need to be aware of it. So the QE actually determines when the HAM is required, and then they also author it and maintain it. So in the hazard alignment model, some of the categories that we look for, like arc flash, usually anything, we change basically, for instance, a battery system that's 50 volts or more would be a arc flash hazard. It used to be a little higher, but we lowered it. Obviously you would require PPE at that point. Just an example. So we go through burns, chemical exposure. Ergonomics is something too heavy for technicians to work with. For instance, for Epcot Forever, we created new pyro barges. So we have these floating barges that go into the water at Epcot. There's 8 small ones that we call the midi barges. There are 2 large ones that we call the 1.3 barges. And the midi barges basically are for 1.4 pyro product. And if you're not familiar with 1.3 and 1.4, 1.4 is like consumer level pyrotechnics. You're basically like the stuff that you can buy on the side of the road, but a little bit more, to it. But then the 1.3s are the big shells, and you have to have, special permission to have all that. But the 1.3 shells, they're obviously extremely powerful, and we have to make sure that, we keep them away from people. We don't, if in case they prematurely ignite, that sort of thing. But anyway, the barges, the techs basically pull out at night. So they're on casters and they're kept on land, and then the techs basically roll them, push them into the water. Then they get towed out to the lagoon area. And if you've been to Epcot, you may have seen them pushing the barges through the water, and then they set them. But so when I designed the barges, I had to make sure that I used, materials that so the techs can actually push them. I can't make them too heavy to where, there's a certain amount of push that's acceptable, a certain amount of force that's acceptable for the technicians to be able to work with. Otherwise, we're putting them in a hazard to possibly be injured. So that's just an example of that sort of thing. I have to keep all of these things, in mind when we design these things. We also look at laser exposure, which is a big thing. We have 3 parks that use lasers at one point or another. And there's a lot going on. So we have to make sure that lasers are a big thing that we look at to make sure that we operate safely. Flame systems, same thing. Pyro, we use pretty much everywhere, and also for shock hazards. And this is just a few categories. This is not the whole list for sure. So I didn't want to list all of them because it'd be quite long. So, so once we identify these hazards, then we talk about mitigations. So we give the priority to the H4, H5 severity hazards. So, as you go through the mitigations, okay, what's the easiest way to get rid of a hazard is just get rid of it, to eliminate it. Do we need it? Is it something that can be done to where we can use some other material or some other way of doing it? So we look at that first, and then we would look at engineering controls. So an example is fence around pyro. So the barges that I was talking about just now was with the 1.3 barges. You see them out in the lagoon, and they have a fence around them. It's a 1-inch chain link fence. So that basically is put there so in case we have the pyro shells are shot from tubes, and basically they shoot straight up, but sometimes the tube will fall over, or that sort of thing. So the fence is there to make sure that the shell doesn't shoot off at an angle into the guest area, because at Epcot the audience is very close to the pyrotechnics, and we use certain pyro for that show that doesn't break too soon, and it doesn't break wide, basically, so we don't expose the guests to any sort of pyro fallout or embers and that sort of thing. So we put a fence around it. So that's just an example of engineering controls. What can we do to build something that will make it safer? And then we have administrative controls that we use, such as, I'm going to use pyro again for an example, keep people away from the pyro. We have criteria as to, for each inch of shell, the 1.3 shell, the people have to be, 75 feet away, that sort of thing. And then also, like if you're talking about the pyrotechnicians that work with the pyro, they have to keep a certain distance when everything's enabled. And then we would use shunting in order for them to approach the pyro in case they need to troubleshoot something. So that's an administrative control. And then we also look at PPE as a hazard mitigation, based on, for instance, again, pyro, we have the people wear safety glasses when they're working with the pyrotechnics, or if you're working with some other caustic material, you have the proper PPE, or if there's an arc flash hazard, you wear the proper PPE, that sort of thing. So we look through all of that. We discuss what the mitigations can be. We talk with the subject matter experts. We talk with our safety professionals, and everybody comes to an agreement as to what these mitigations would be. And then, it can escalate. We can move it up to different levels of acceptance, and then we would engage, senior engineers within our design and engineering department and that sort of thing to validate. So it's not just us necessarily coming up with everything. Certain things that we need to make sure that we have validation for, we will move it up to the next level. So in talking through mitigations, sometimes maybe we have a mitigation that we've used before that would apply to this. So we look at those first. And we say, so what can we do that is acceptable, that we've already accepted and we've shown that is an acceptable mitigation. We'll do that. And then we also ask for input from the SMEs and the professional engineers to say, what can we do? Will this work? That sort of thing. And then, like I said, we can elevate it for a different level if we feel that it's something that we're not quite comfortable with or we're not sure about. And then we also create a mitigation report that we share. So basically it identifies the hazard, and then it reports out what the mitigation is, and if it's accepted, and then implements it. So we have to check all of that off as well. And then what we come up with after talking through all of that, we do the QE does a project dashboard, and the project dashboard is the document to track the critical deliverables that are required for the project, or a part of the project, or part of like a show element to open. These have to be met in order for it to be used. So like I said, it's maintained by the QE, and then what it does is it includes the list of deliverables, the due date, the percent complete, the current progress, and then we go through basically the different areas. Like we start with, there's design, and then there's all these deliverables, testing deliverables, documentation deliverables, training, opening, and closeout. So it goes, starts from the beginning, goes all the way through. So again, this process is started early and is used often through the design process. So some of the examples of the deliverables on the project dashboard would be, was the hazard analysis done? Do we have the mitigations report done? Do we have the drawing packages from the vendor or from the engineer? Do we have the engineering calculations? Weld certificates, like we require anything that is welded to be certified. Do we have an acceptance test plan, the ATP? Do we have the manufacturer's requirements, and do we have job plans? And again, these are just examples of the deliverables, and it really just depends on what the QE feels is needed in order to meet all of the guidelines. And a lot of these things are, used on pretty much every project or every, event that we use. And this process, I want to say that we often operate with really accelerated timelines. So we're talking, we had a show, I think we had like 4 weeks to basically design, install, and execute it. And so sometimes this process has to be accelerated, and we take that into consideration when we go to do the design. So we try to keep it to where what can we do within this period of time safely, and that sort of thing. So the DAHA process can be kind of massaged in order to meet the deadlines that we're trying to meet based on, when we're asked to meet them. So basically then once we're going through the process, we're trying to do, we have things mitigated. We meet all of the criteria on the project dashboard. Then what's the next step is the QE will basically assign or basically turn over a memo to begin rehearsals. So it's a little different because what the QE is saying is things are safe enough to where you can do rehearsals, but you may not be able to do rehearsals with this piece or that piece until we get all of the requirements on the project dashboard met. So because there's things that we're working through or things that haven't been delivered yet. But for instance, for Epcot Forever, we start rehearsals with the jet skis. They need to be able to go around the lagoon and get their bearing. And they were trying to, familiarize themselves with the layout of the lagoon and what their obstacles are. But we can't use the pyrotechnics yet until we've, test the pyro barges that we just built, that sort of thing. So the QE determines what requirements need to be met. And then those are basically determined from the project dashboard. So for instance, Catherine, our QE will say, okay, well, you need this, this, and this to do the turnover, the P tour. And then she will basically approve that. And then she will submit a memo that says, okay, you are allowed to do rehearsals. Here's your P tour. And then the next step after that is the okay to use memo. And that is required to open a show or to use a certain show element. And then again, the QE determines what requirements need to be met. And that's from the project dashboard. So if everything in the project dashboard is met, the QE will basically write the okay to use memo, and that goes to the head of entertainment for whatever area that the show is happening. They include basically all of the executives to say, okay, you're able to do this show now. You're able to use this show element. No problem. We're good to go, sort of thing. So that is your ultimate goal. To get that okay to use memo, you want, everything. We've looked at everything. We've gone through everything. We've made sure everything's, as safe as possible. And we all agree on that. And that's when that comes in. So basically it's a way to say, yes, we have done our due diligence and we have looked at to make sure everything was done per our local national company standards. And we all agree that that's okay. So, and again, the okay to use and the PTOR aren't necessarily used for everything that we do. Like that's determined basically from the get-go if that's going to be required. For instance, I just finished doing a scenic treatment on a pontoon boat for the 50th anniversary. And there was some question as to, well, do we need an okay to use for that? And the QE basically said, no, we don't need to do an okay to use, but we were going to do a review, make sure the scenic doesn't have any sharp edges or doesn't, occlude the driver's vision or anything like that. So we kind of, again, it's kind of a due diligence thing. We look at it and we go, okay, this is going to work. There's no inherent danger here. You don't need an okay to use, but if we find any issues, we'll correct them before we open, that sort of thing. It's not as, that obviously the review isn't as stringent and as it would be if we needed the PTOR or the okay to use, because sometimes things are just simpler and we already know what the best practices are and the safest practices are to implement that. So that's basically it. I didn't want to get too much in the weeds because the process can be, quite complex depending on what it is that we're doing. For instance, the new Harmonious show that just opened at Epcot, it's a massive show. It is, this is, 4 years in the making, something like that. There are massive mechanical structures in the lagoon that have complex systems, complex safety systems required an army of people to design, engineer, validate, and that will get into, once you get something like that, it tends to, you get into more of the engineering stuff. You get into the failure mode, effects analysis, stuff like that on their end. And we kind of sit in and we provide input on that sort of thing. And so it can be complex depending on what we're doing. Sometimes it's as easy as identifying hazards, but when we're dealing with things that we've never done before, or we're designing, from scratch, and isn't something that we can just buy off the shelf, then it takes a longer time, a longer process, a lot more than kind of what I've laid out. I've kind of made it simple, but it really does involve a lot of effort from a lot of people in order to make things safe. And that's really what it's about is, what are we going to do to make our cast members safe and our guests safe? That's it. And it really comes down to that more than anything. We are, that is paramount. And then our, whether or not the quality is good, comes later. If we find something that's just not going to be safe enough, we just won't do it. So that's kind of it. Any questions that you guys might have, feel free to throw at me.
Eric, this was great. Thank you. There have been a couple of questions that have come up in the Q&A panel. And I meant to mention before I let Eric get started, if you have questions, feel free to throw them up in the chat or in the question and answer panel, and we'll try to circle to them. Mary and I have come up with some questions in case you don't have any. So we'll see we can quiz Eric on, but a couple have come through. The first question from anonymous attendee. I don't know who that person is, obviously, but the question is, do you have a document that is utilized to guide you through the HAM process so you've properly evaluated the system, sort of a check the box kind of thing?
Yeah, basically, well, we do basically the hazard, the HAM basically does that for us. And we basically put in, I would love to be able to share one with you, but I'm not really allowed to. So I'll just kind of explain it and hope that you understand that what it is we identify it, we say what the mitigation is, and whether it's accepted or not. And we do have a tracking sheet that shows that. And that's pretty much what the mitigation report does. Is it'll show what the hazard was that was identified, where are we in the mitigation process, what is the mitigation, and whether it was accepted and by who. So I hope that answers your question.
Oh my gosh, more questions are coming as we speak. Fantastic. So I think this will be a quick one from Kylie. Do you work with Anaheim and Orlando or just at Disney World?
I work at mainly Disney World. There are times where my team will work, we'll go to California and work with the Anaheim team. I personally haven't worked in Anaheim. I've been sent to different, Chicago, Denver for different things. But to answer your question, yes, we as live entertainment are pretty much global. So we service and we help out depending on what it is. So for instance, if it's something that one of our technical directors have experience working with, we'll send them to Anaheim if they're doing a similar thing. So we do share it, but I personally am based in Orlando, and that's pretty much it.
Gotcha. Thank you. Ashley has asked, this might be a longer answer. What has been your greatest challenge to overcome in designing at your time at Disney?
For a specific answer, it was the Epcot Forever kites. We were I don't know if if you've all seen the show, when it first opened, we had the kites that were being towed by jet skis, and we really wanted to make the kites look super cool. So we added, basically LED strip lights on them. And we wanted to control them with a Grand MA console via wireless protocol. We designed basically a circuit that, would take that info and basically change the colors and that sort of thing. And it was an Arduino, I believe, that we just threw in the box. But there were so many aspects of doing this because we had to, well, what's the shock hazard? Because they need to be on a battery. What is that battery? It's lithium ion. Oh my, okay. And we're going to put lithium ion batteries near water. And just so anybody doesn't know, like that's a really bad thing to put lithium ion in water. So, what are we going to do about that? Okay, so we had to design a waterproof box to put all our electronics in and make it waterproof. And then we had to do these lights on the kites, and we had so many problems with those lights to work properly. We had several antennas out in the lagoon just for RF coverage. We had to work within a certain frequency spectrum that wasn't going to interfere. Like, believe it or not, Epcot has, you're gonna laugh, but Epcot has garbage cans that have a transponder in them that basically when the garbage cans are full, they send a signal to the custodial base to go empty the garbage cans. And those work on I can't remember if it was what frequency spectrum those worked on, but we had to steer clear of that, so that was like, and then of course we have RF from wireless microphones and RF from comm and all this stuff. And we had to be really careful about that. So there was that issue. And then when we got into testing the lights, they broke a lot because the kites, when they landed the kites, they basically just let them kind of fall into the water. And they tried to land them softly as best as they could, but sometimes they would smack into the water. The lights would break. The consistency was an extreme challenge to do that. And we actually spent more money developing better waterproof boxes because the ones that we had weren't doing the job very well. Then we had to worry about the pyrotechnics on the kites, whether those were going to work consistently. And it was a constant battle all the way up until opening. And even after opening, we were constantly having to fix these lights, and we were just beating them up. Plus the water in the lagoon, we don't know, like it's a water of the state. So basically, it's refreshed basically. So, but there was something in the water that was corroding the LED strips. And so we had to do a conformal coating on it. We tried, oh my gosh, so many different things in the different light strips, but that was probably the biggest challenge I've ever had to deal with, was getting those lights and that pyro on those kites to work consistently. And it was a constant battle all the way until we closed the show for COVID. And, but, it's one of those things where it's a learning process. And yes, it's very frustrating, and it's, very, like, how am I going to, but we think through these things, and it's a challenge, and that's what makes things kind of exciting too, is what are we discovering in these challenges, and what can we now apply to other things that may have a similar a similar challenge, that sort of thing. So that just in my head immediately pops up was that show and those kites. So but watch it on YouTube. You'll enjoy them. They look awesome.
I think what's great. Sorry, I didn't mean to cut you off, but I think what's great about that answer is that, and we've had other guests and they've asked similar questions, and I'm always struck by how what seemingly is a simple thing becomes a really complicated problem. Mm-hmm. Right? Just put lights on kites. That shouldn't be that hard. Well, there's all these things. And that's always fascinating to me about the stuff that we do in the live entertainment industry is what seems really simple. It can be really, really complex and require a really nuanced approach.
And to tag on to that, Disney is well known, in not only in the live entertainment, but for movies and cartoons is we do what they call bump the lamp. And there used to be a class or like a seminar that our Disney training people would give to people from other companies. And I used to run the AV for it. So I've seen it a billion times, but they would show the clip from Who Framed Roger Rabbit. And they would show Bob Hoskins grabbing Roger, by the neck, and he kind of swings him around, and Roger's head hits this lamp, and it's a real lamp, and it hits the lamp, and the lamp's swinging, right? And then they show a close up of, the animated character and Bob Hoskins, talking, and you see the shadow of the lamp, the different light source on Roger's face, so the animators had to put that in, and that's something that, could have just easily, that was hours and hours of having to shade and, constantly and do that to where it looked like the lamp shadow was swinging on his face. But they did that to give more authenticity, to do something that made it feel more real. And that's what we do, is we try to do something, better, or try to do something that people haven't seen before. And we wanted to do that with these kite lights. Yes, we could throw some, Philips Hue strips on there, and I could hold the remote control or something and turn them on. But what we wanted to do with them was to be able to color blend and to chase and to do sparkle effect, because we, on the Arduino, we created a sparkle effect for them to work, and we made it more complex. That's because we wanted to, but man, when it worked, it was so cool, and it was totally worth it. It was
sure.
And the kites were such a beautiful moment, and we were happy that we were able to do that, because we could just turn them to blue, we could just turn them to red, and it wouldn't look as good. It wouldn't tell the story as well as if we had just thrown some off the shelf stuff on there. So
sure. That's a great way to put it. It wouldn't tell the story as well. There are 3 other questions. 2 of them are kind of big, and we've got about 15 minutes left, so we're going to try to squeeze them in here. The first is from Ed, and I'm going to paraphrase a little bit because there's a lot in here, but basically, not all of us have access to the financial resources of the House of Mouse, and so how do we approach risk assessment to still sort of push the boundaries of physics in our shows, even if we can't necessarily afford a PE to sign off on something, and how do we do that and still maintain a safe working environment? Like, what is your sense? No one's going to quote you, right? There's no legal apparatus here, but what is your sense of how do we do that, and how do we establish the boundaries of that?
That is a really good question, because yes, I'm spoiled. I have a lot of resources afforded to me, and I think the best way is to, if it were me, I would research the heck out of whatever I wanted to do. See if you can find people that, whether they're friends or you have contacts with USITT, or you have somebody that you can bounce ideas off of, or at least validate. When it comes to a life safety component, I'd want to say I wouldn't want to mess with guessing. You really do need to have somebody validate it, and that's something you would really need to build in your budget. Now, do you need 10 people? I don't think so. But if you were to go to a subject matter expert, I'm going to say, for example, you set up an outdoor, you wanted to plan an outdoor music festival, and you wanted to build a stage, and it's outside, and there's a lot of wind load on it. And, you would need to go to an engineer. Well, first of all, you'd have to permit it. So you would need to get it engineered anyway. But just an example is, you don't want to go, oh yeah, these water-filled, buckets will work. These, water-filled, whatever. Yeah, that'll work. That seems heavy enough. Like, you never want to really do that. And, to answer your question in terms of having, limited resources in order to do that. But, I would say is, if you don't have enough money to do it right, do you even want to do it? Or do you want to simplify it to where you can do it safely? I think that's what you just need to look at is, in order to do this, we need this. And, I think it really only takes one validation from a subject matter expert or somebody with a professional degree to help you out. They're not terribly expensive. I can tell you, I think, if you get engineering for a basic truss structure, it may be about $1,500, $2,000. Yeah, that, in the grand scheme of things at Disney, that's not a lot, but what is that buying you? That's buying you sleep at night. That's buying you peace of mind. That's buying you, stuff like that, if it's worth doing, do it right. And and at the very least, engage people for their opinions, people that are in the know. At the very least, do some due diligence to make sure that what you're doing isn't going to hurt somebody or yourself, for that matter. That, I guess that's my answer. I hope that really answers your question. But yes, in the real world, we don't have millions of dollars to throw at things. But at the same time, there are so many incidents like Indiana State Fair, and you had the club fire a long time ago, of people just kind of thinking, this is safe, I can do this, no big deal. And people died. So you got to think about that. You really have to think hard about that.
I appreciate that answer, Eric. And Ed, if I misparaphrased, feel free to throw a correction up into the chat. And I'll also say, Ed and Mary, I actually have an outside the box idea related to that I'd like to circle back to the three of you or the two of you on. I think it might be an interesting opportunity. Shep has asked, with the accelerated timeline for certain projects, have you ever found yourself having to cut an element that doesn't meet safety and quality standards? And then how do you navigate that decision? And I imagine part of that is, how do you talk to the stakeholders about that decision?
Yes, absolutely. Absolutely, we have. Mainly, again, we engage early in the process. So usually that pain isn't as bad when you're giving that. I recently ran into a big challenge. I was working on the Warrior Games they were supposed to be last month. They were canceled. The Department of Defense actually was the stakeholder for that, and they canceled it due to their reasons. But the original design was we were going to put a monster truss structure out on the baseball field at the sports complex, and my art director really wanted to cover pretty much 90% of this thing with some sort of graphic or scrim or something. And then, of course, you structural engineers kind of go, oh my gosh, that's a giant sail. And yes, and, so basically I go through the process. Okay, well, I'll see, can I make the vision happen? So then when I get with the engineers and they say, well, for this structure, in order to meet the guidelines for permitting at 94-mile-an-hour winds, you need basically 60 tons of ballast. And I can tell you, my rigging department does not own that much ballast. We don't have any of that. And where he wanted, it was going to be pretty much impossible. So my job is to offer solutions, is to offer options. And it's not, the main thing you want to keep in mind is not necessarily, no, you can't do that. It's a yes, if, right? Yes, we can do this if the engineer says that it's okay to do it. It's okay if we have 60 tons of ballast and we could put it there. So then what I do is I usually come up with plan B or C. And I say, well, if this engineering is not going to work out, just so you know, so we would have to cut the wind load. What are you willing to give up? And so we give options. And I think that's the best way to do it, is to provide options. If you've done your due diligence, again, if you've engaged the right people, it's a lot easier to sell that change in vision to the stakeholders, to say, well, we had an engineer validate this, and it's going to cost you this much money, and a lot of times then they decide, well, okay, we'll do something different, or, or instead of this, maybe we do this, and, and see what they do. But you always want to offer solutions, and always have your back, back yourself up, get the validation from other people, so you're not the one, being negative Nancy, basically. So it is a fine line to navigate, and it does take a little bit of personal skills to do. So I hope that answers your question.
I think that's also a really great answer, right? And it covers a lot of things, right? The yes if or yes and approach, right? Presenting options. But I think also, and you mentioned this in your presentation, and you said it many times, that this process starts early and happens often. And that speaks to creating a culture of the process where safety is a key stake throughout. And it's not that people don't think about don't think about safety, but sometimes, particularly at some levels of the live entertainment process or industry, there is vision first and safety gets talked about later, as opposed to it being an integrated part of the conversation. And so I really like that idea that start early, talk about it often, and create a culture of it.
It saves you so much time and so much money. If you engage early and often, you'll trust me, it'll be a lot easier.
And then people start thinking, people who don't normally think in that mode are thinking in that mode all the time. And so everybody's on the same page, and that we're all trying to create a vision, and we're all trying to do it safely, and we're all thinking about all the same things, as opposed to coming at it at an antagonistic way. We've got about 7 minutes left. We got one more question that came up, and then I'm hoping we have time for one more from Professor Pillot. Anonymous again, maybe a different anonymous, says, how far deep do you get on, I imagine this means individual components with the HA process? And I think you kind of touched on this when you talked about engineers and FMEA, but can you speak to that again?
Yeah, it honestly, it really just depends on what it is. The complexity of the hazard, and what's and yes, at some point we get into failure mode, effects analysis on the engineering level. But it really, it's hard for me to answer this because it really just depends. It's, if you have a structure that is mechanically driven, that's a whole set of rules, then you're introducing, basically collision hazards or pinch hazards or stuff like that. And I think you have to piecemeal it. You have to look at each individual part and, what that's going to entail and identify within those components. So for instance, like Harmonious's, their set pieces in the lagoon are pretty complex. There's hydraulics, there's pneumatics, there's pyro on them, there's lighting, there's electrical systems. And each one of them, we go through to say, what happens if, this failure happens, what do we do? And we do failure mode effects analysis in the sense of troubleshooting the show in terms of, okay, well, if again, Harmonious, there's big water fountains on these set pieces. So if we're not able to wet down the structures, because we do a pre-wash, so because there's a lot of pyro, so we don't want things to, not that anything's really going to catch on fire, because we FR treat pretty much everything, but what can we do to protect our assets? If the fountains don't work, then what? So we go through that and we say, well, if the fountains don't work, then, if it rained an hour before, we'll be okay, or, that sort of thing. So we look at it holistically, and then we look at it depending on what the component is. And yes, we will get very deep into it, depending on that complexity or what that hazard is. If it's an extreme hazard, we do have to dig deep down to make, what is exactly going on? What are the components involved? Yeah. And that sort of thing. And we'll get into it depending on, what it is. So
my favorite answer to any question is, it depends. I love it.
I know, right? I know it's very vague, but it really does. It's some things are simple.
I think it's accurate. There are some things that are simple and some things that aren't. Yeah.
Exactly.
Mayor, I've dominated this conversation. Do you have anything in the last few minutes that you wanted to ask or bring up?
I just have a quick one, but it's really not that quick, I guess, if I'm completely honest. But thinking about all the possible sources of risk that you've been exposed to, is there one that is kind of like a hot button for you that's like, oh, you kind of clutch your pearls just a little whenever you know that this one's coming and being onboarded as part of a project, when it worries you or keeps you up at night?
Yeah, anything having to do with permitting with Reedy Creek Improvement District, the building department, because they change rules on us all the time. And for instance, the Warrior Games Trust that I mentioned earlier was one of those things that kept me up at night, because when the design was introduced, myself and the rigging manager basically, got with each other and said, man, that's gonna be crazy. I don't know if we're gonna be able to do this, and it's that sort of thing. And it took our engineer, they looked at it for 3 weeks to try to make it work, with different placement of ballast. And we're relegated to a certain amount of ballast in one spot. And that usually always gives me sleepless nights as to whether something is going to be approved by the district, because their requirements are the most strict in the country. And that I am, I can say that safely because they require things to be engineered and, way above and beyond what your normal national codes would be. So there's a lot more involved with dealing with them than, and that's the part that makes me worry, to make sure that what is the design going to work? Is it going to work for, when you have to get permission from a government entity, basically, there's a whole different level of stress and pressure, because you really have to have your stuff together and be able to answer questions.
Stakes are higher.
Yeah, I mean, we've had a lot of challenges. It's not like, oh, they're a pain in the butt. It's just that's their requirements, and again, they will change things, and we have to roll with the punches, but they're great partners to work with. And we've given them stuff with very last minute notice, like, oh my gosh, I need to put this set piece in outside at Disney Springs in like 4 days. Can you approve this permit? Can you push it through? And they'll be like, yeah, we'll help you out, sort of thing. So but to answer your question, it's mainly like outdoor stuff. Hurricanes, anything weather related in Florida. There's pop-up storms, there's microbursts. That's the stuff that kind of keeps me up at night. What am I going to do if a hurricane comes through? What's my hurricane plan? What's my high wind action plan? What's, weather plan, that sort of thing. So that's
awesome.
So many things to think about. Eric, we're at 1 o'clock. Thank you so much for taking the time to talk to us today. This was great. I'm sure other folks think the same way. Mike here wrote up in the chat that basically said this was really well done, and thank you so much. There's a whole lot to think about, so I just want to make sure we shared that out loud. Folks, thanks for attending. We've got a couple of other exciting conversations coming up in November and December. Keep your eyes open for announcements about that. But thanks for joining us, and we'll see you all soon.